Hey guys, very good afternoon to all of you. Welcome to the first session on modern maths, which is permutation and combination. So guys, we are going to get you the practice problems from this topic of permutation and combination for CAT. This is one of the important topics, but for CAT, I would say it is slightly lesser important. But for exams like XAT, IIFT and other exams, SNAP and all, this is one of the important topics, right? So, this has a continuation of a topic called probability. So if you're good in P&C, your probability also becomes easier, and probability is one of the favorite topics of XAT. So on an average, every year in XAT, you get about 1 or 2 questions from probability and probably 1 question from P&C. So you can expect a total of 2 or 3 questions from P&C and probability together. In CAT, I would say this is relatively lesser of importance. You can have anywhere between 0 to 1 or 0 to 2 questions. There have been years where there are no questions asked. So that way, to be very frank, for CAT, I would not say this is that great, but NMAT, your SNAP, IIFT, XAT, any of these other top MBA entrance exams, this has a decent amount of weightage. So let's go ahead and take a look at what kind of questions come over here. Now guys, one basic assumption that I'm making, this is a session for students who already know the basics of P&C. So you should be at least, if not perfect in it, at least you should be aware of some idea about this topic. It's not a complete theory class. So please keep that in mind. I get a lot of comments from students saying that you're only discussing the problems. But again, we have different types of sessions. If it's a session which is based on theory, then you'll have a lot of theory coming from my end and little, some number of questions. But if it's a practice session like this, you will have little theory and a lot more of questions, right? So that being said, let's start off with some basic idea about P&C. I will not get too much into it, but when we are solving problems, I'll try to give you the recollection of the theory behind the problem, right? Is that good enough for all of you? Yes, Aku Patil, good afternoon. Yes, in NMAT also it's important, Aku. That's very, very correct. So let's go ahead, guys, and let's understand first what is the meaning of P and C. P stands for this word permutation, and C stands for the word combination. So basically, this topic in Indian books, if you look at, they come under the name of P and C, permutation and combination. Sometimes they also are called as combinatorics. But if you look at certain foreign author books, they call this topic as counting problems. Counting problems. Now, you might get confused as counting problems. Counting problems is not, addition or subtraction. This is the typical way in which the questions are asked in your exams, right? So they ask you how many ways, how many different arrangements, all these. So when you're saying how many ways, you're counting the number of ways. That is the reason these are called as counting problems. So you need to be aware of the terminology used depending upon the book. All Indian author books, mostly they come under your permutation and combination, but if you're looking at GMAT books from foreign authors, they call it as counting problems. But okay, it really doesn't matter. The topic is the same, the concept doesn't change, the formulas are the same, it's just the name that changes, right? Just putting it out there so that you don't get confused if you come across this kind of a question. Now, what is permutation? Permutation is counting of things. It is counting of different possibilities or arrangements in a different possibilities or arrangement of particular items. Now let me go a little bit in depth here and try to understand the meaning of permutation. So if you're talking about, I'll give you a simple example. If you're talking about seats, chairs or places where people can sit, let us say there are 6 chairs. Now, if you notice, the moment I say 6 chairs, you can clearly see in a straight line, the left chair is different from the right chair, the middle chair, so you can call it as first position, second position, and so on, correct? So, while the chairs themselves don't have a name, because the way in which they are sitting, the way in which they are arranged already, you can say that this is chair number 1, you can say that this is chair number 2, and so on and so forth. So, you can call these as distinct chairs. So here the word distinct is very, very important. What is the meaning of distinct in the terms of P and C questions? Distinct means you can identify one separately from the other. For example, if I say there are two baskets, there are 2 or 3 baskets like this. There are 3 baskets like this. Okay, and they are all of the same size, same shape, same color. Right? So you cannot distinguish between first, second or third because they are basically in a circle. So in a circle there is no first, there is no second, because in clockwise direction everything follows the other, or anti-clockwise direction also you take, everything follows the other. But the moment you make them sit in a straight line, you're making baskets, and the order of the baskets is important. So this is basket number 1, the leftmost basket, basket number 2 and basket number 3. You're putting them in a position. Then this is called as naming. Okay. So what is the meaning of distinct? Distinct is you can figure out one basket from the other. So typically what happens in the kind of questions is they give the word distinct or identical. They will use the word identical. So what is the meaning of identical here? Identical means if I give you 3 things in my hand, you can't differentiate one from the other. Okay, but if I say 3 identical baskets are put left, right and center. Now it clearly means the left basket is different from the right basket and the right basket is different from the center basket. So you have to be very careful how the positioning is being given to the items. So in my question, when I'm saying chairs, I don't have to mention they are distinct. Why should I not? Why don't I have to mention distinct chairs? Because they are anyway sitting in a straight line. So if they're sitting in a straight line, my chair number left will be called as chair number 1, second chair can be called as chair number 2, third chair can be called as chair number 3 and so on and so forth. So whether they're distinct or not is immaterial to me, because anyway I'm able to identify the difference. This is the first part, slots. These are the gaps or slots. What are you filling them with? Typically what do you put in chair? You make people sit. Let's take that example. So there are 6 people. Now, people are also by definition distinct from each other. People are also different from each other. So you have A, B, C, D, E, F. So you are making 6 people sit in 6 chairs. The number of ways in which this can be done is called as permutation. So in permutation, it is arrangement. It is basically arrangement of things, typically in slots. Sometimes it could be chairs, sometimes it could be baskets, sometimes it could be bags, whatever else it is. So now the idea of permutation and the number of ways to calculate this has a formula which is given by NPR. So what does NPR represent? It represents N people being made to sit in R chairs. So if N people are being made to sit in R chairs, how many different ways can you make them sit? That is given by this representation NPR. Or a general term, N things being made to fit into R places. N different things being made to sit or fit into R different places. Please notice N is also distinct, R is also distinct. So N different items are different places. That is given by the representation NPR, and the formula is N factorial divided by N minus R whole factorial. Right? This is the meaning of permutation. Clear? Now, few things that you will get from NPR. If you look at 6 people in 6 chairs, so this becomes 6p6. This is 6 factorial by 0 factorial. So firstly you need to understand 0 factorial is equal to 1. So this is nothing but 6 factorial itself. So you should not be using this formula every time. If there are number of people and number of gaps are same, you can straight away write the number of permutations possible as that number factorial, 6 factorial. But if the number of people are more and the number of chairs are less, it is given by NPR, which is N factorial by N minus R factorial. Okay. Then we have another thing called as combination. Now what is combination and how is it different from a permutation? We already understood permutation is where you are arranging things, people, items in particular slots, in particular places. Combination is not arranging. This is basically grouping. This is basically grouping. What does it mean? Let's take an example. Let us say I have A, B, C, D, 4 people. Okay. Now my question is, I want to form 2 groups, group X and group Y. Group X should have 3 people in it. Group Y should have 1 person in it. How many ways can I do this? If you notice, I am not worried about how are the 3 people sitting in group X. I am just choosing 3 people to go into group X. Automatically the last person will be going into group Y. How many ways can I do this? So simply if you do this, A can come here, in which case BCD is here. B can come here, in which case ACD is here. C can come here, in which case ABD is here. And D can come here, in which case ABC is here. So you can see that totally there are 4 ways in which you can group. Right? So this is called as combination. Here, whether you're writing BCD or CBD or DCB doesn't really matter because you're just forming a group. You're not making them sit anywhere. This kind of a counting where the order, so the order does not matter. Order does not matter is called as combination or grouping. So there is a formula for combination also. When you have n people, okay, when you have n people and you have to choose, select r of them, the number of ways in which you can do that is given by NCR. Now this basically expands into n factorial divided by r factorial into n minus r whole factorial. This is the formula for NCR. Now please keep in mind here also always n are distinct and r are distinct. Okay. So here the question is not places. Here I have 10 people. I want to choose only 3 of the 10. I want to choose only 3 of the 10. How many ways can I choose 3 people out of 10 people? So there are no places here. It's grouping of those things itself. So in this example, my n equal to 10, my r equal to 3, hence 10C3, which is nothing but 10 factorial by 10 minus 3, 7 factorial into 3 factorial. Okay, so this is the way in which you remember or write your NCR. Please remember, both these formulae are only applicable under first one condition. The n has to be distinct. N has to be distinct. You cannot apply this formula directly unless n of them are distinct. There will be cases where these are not distinct. In such cases, you cannot apply the formula. We will see what to do there. We will see how to go about doing it. Clear? Okay? Joydeep, I hope this is clear. When to apply permutation or combination? See, don't blindly believe that formula will solve. Guys, remember, in the last so many years of CAT, a direct formula question will not help you. What you need to understand is the concept behind. Apply concept and a standard formula, that's how they'll give you the question. They will not give you a question where you put an NCR or NPR and you'll get your answer. Very rare. Very, very rare. There'll be a small twist. And you are supposed to understand the concept to understand the twist and therefore change your answer accordingly. Okay? Now, if you want to look at the questions from, so while you understood what is permutation, while you understood what is combination, there are 2 things. Don't worry, Joydeep. If you carefully follow what we're discussing, I hope you will be becoming better and better in your PNC with a little bit of practice. Okay. Now, let's go ahead and take a look at what is the, there are 2 rules which I want you to follow. These 2 rules, it's not my rule, these are standard rules in PNC. These are called as, first is the fundamental rule. Fundamental rule of addition. And second, fundamental rule of multiplication. I'll explain what these 2 rules are. In fact, these formulae that we got, remember these formulae have to be derived, right? They don't just drop out of thin air, they are derived. So these rules that we are talking about, fundamental rules, are the basis on which you will create these formulae. The formulas are derived. And it is very, very important for you to understand these fundamental rules, because most of the CAT questions, XAT questions, any of the other entrance exams questions, while the formulae exist, they do not ask a direct formula question. They will ask you based on these rules with twists and turns. So let us understand what are these two rules. The first rule, I will start with the second rule actually. The second rule is easy for you to understand. It is the rule of multiplication. What is the rule of multiplication? The rule of multiplication says, let us take an example to understand this rule of multiplication. You want to go from A to B. A and B are cities, and there is a city C. Very standard example. You can go from A to B in three ways. Three routes exist to go from A to B. And to go from B to C, there are two routes, right? So if I want to go from A to C is my task, my job. What is the process of doing A to C? I have to go from A to B, right? And I have to go from B to C, correct? So my job of going to A to C is not a direct job. It has task number 1, first I have to go from A to B. Task number 2, I have to go from B to C. So the fundamental rule of multiplication says, whenever you have an AND, which means two tasks have to be done, there's no choice, you have to do both. In such a case, the total ways of completing them both, is given by the number of ways of doing this, and the AND will become multiplication into the number of ways of doing this. So if you say 3 ways of doing A to B, going from A to B, 2 ways of going from B to C, then the total number of ways from going to go from C from A will be given by 3 into 2, which is total of 6. So the fundamental rule of multiplication says, whenever you say something and something, so find out this and change it into multiplication. And the first task, find the number of ways of doing it alone. Second task, find the number of ways of doing it alone and multiply them. That will give you the final answer. So this is how the second rule has been defined. Now let's understand the first rule. If you understood the second rule, the first rule is similar. The first rule is rule of addition, fundamental rule of addition. The addition rule says, if you have to do, so let me give you an example. If a thief has to enter a house, there's a house. Okay, a thief has to enter a house. There are 3 doors and there are 2 windows. The house has 3 doors and 2 windows. Now the question is, how many ways the person can enter the room? Now please don't get confused by this and. This is English and, okay, not the question and. Leave it aside. So the house has 3 doors and 2 windows. How many ways can the thief enter the house? Now, first of all, look at the problem statement. The problem statement is, I want to enter the house. Let's say I'm the thief. What are the options in front of me? My option is, I can use the doors. This is one task. Or, now it's not and. Remember, why will I use both door and window? I have to enter only once, correct? So, either I'll use a door or I will use a window. So, or, this is the problem statement now. Door or window. Correct? So, now the first rule of addition or the fundamental rule of addition says, or gets converted into addition. And gets converted into multiplication, or gets converted into addition. So now, how many doors are there? 3 doors. How many windows are there? 2. So total ways of entering the house is this or that. Total is 5. Is this clear? 3 plus 2, which is 5. So this is the fundamental rule of addition. Clear? Can I have a quick response from all of you? Is this basically understood by all of you? The fundamental rule of addition and the fundamental rule of multiplication. If you understood this, please comment very quickly and we can move on to the next step in learning. Is it ready? Are you guys done? Alright. Tarak, Joydeep and others, can you also please confirm? Okay, let's move on, guys. So now I'll give you a small question. Let us say there is a house with 3 doors and 2 windows. It has 3 doors and 2 windows, same example. Now the question is, how many ways can a thief enter the house and exit the house? This is the question. How many ways can the thief enter the house and exit the house? What is the answer? So first define the problem, write the problem statement, then start converting your odds and ands into multiplication and additions. Tarak, Joydeep, any answers, guys? Right, let's go ahead and take a look. So what is my problem? My problem is entering and exiting. I have to enter and exit. This is my problem statement. So I have to convert this and into multiplication. And I have to understand how many ways can I enter and how many ways can I exit. Now, entry, there are 3 doors and 2 windows. So 3 doors or 2 windows, I can use any of these. Hence the total is 5. Exit, again I can use any of the 3 doors or any of the 2 windows. I will only use one of those, not all. So this or is addition. So 3 plus 2 is 5. So my total answer is 5 into 5, which is 25. If I change this a little bit, how many ways can a thief enter the house and steal, let's say, a big item, refrigerator? Assuming that refrigerator cannot be taken out through a window. That's the twist now. How will this change? Now, the problem statement is still the same. Entry, fine. All 5 ways you can enter. But exit, you are coming out with a refrigerator. So you cannot use the windows now. So you cannot say I will exit through door or window. Windows are gone. So only doors are there. How many doors? 3. So the answer is 15. So this is how you change, and this is how the questions are asked. Most of the CAT questions are going to be like this, where if you notice, we are not using any formula at all. What are we using? We are using the fundamental principles. These are called as fundamental principles of counting. And this is how the questions will be given to you. Okay? So there are certain points to remember. We will learn a lot more about concepts, but this is the basic idea. But let's go ahead and take a look at some basic steps, points. Permutation is used for the list of data where order of data matters. That's what I told you. Permutation means arranging. Arrangement means it matters who's sitting first, who's sitting second. And combination is used for a group of data when you are selecting, making a group. There the order does not matter. This formula we already know. It is basically, what is NCR formula? NCR is n factorial by n minus r factorial into r factorial, correct? What is NC n minus r? You'll notice this is basically now n factorial by n minus of n minus r whole factorial into n minus r now. This will turn out to be the same. You can see this r factorial, this is r factorial, n factorial, and then the same. So NCR is NC n minus r. So which means 5C3 is same as 5C2 because 3 is 5 minus 2. So if I ask you what is 10C8, it is same as 10C2. So this is one of the simple neat formulae that you will remember. You will have to remember. This we already saw. 0 factorial is 1. Now, this is a formula which we will use. We'll come to this case a little bit later. But the question here basically talks about if there are n distinct items, okay, n distinct items, number of ways in which you can decide to give them away. Number of ways in which you can decide to give them away to somebody. Doesn't matter. You're giving it away. How many can you give away? You can give 0. You can give 1 item. You can give 2 items. You can give 3 items, like that. You can decide. So that is given by the formula 2 power n minus 1. We'll come to this in one of the examples when we use. So don't worry about it. Then of course we have something called as circular arrangement. Now please remember, linear arrangement is different from circular arrangement. Okay, so in linear arrangement we use NPR funda, right? Arranging people into places. But in a circular arrangement, This is a specific case where there is no left and there is no right. So let's say there are 4 people or 5 people sitting. If I ask you who's sitting first, there's no answer to it. Why? Because circle does not have a starting and an ending point. So in a circle, the first position belongs to everyone. But if the one person is sitting, then let's say A is already sitting here. Then now I can say each position is different. Why? This will be called as right. This is called as left of A. Correct? Because now A is there. So once A is sitting, the second position will be called as left of A. And this will be called as right of A. This will be called as opposite of A. So now you have identification of the other 3 seats. So a circular arrangement is done by the logic that if there are n people to be seated in n chairs. Now remember, this is always for n people and n chairs. Then the number of ways in which you can make them sit in a circle is n minus 1 factorial. N minus 1 factorial. Okay? Joydeep, don't worry, point 4 will come back later. That's why I said this we'll actually see some examples and I'll explain why it is. So for now, don't worry, Joydeep. Okay? So for a circle, when you're making people sit in a circle, it is n minus 1 factorial. Whereas same n people sitting in n places, the answer is n factorial. We already saw that. npn is n factorial. Correct? But in a circle, it is not n factorial, it is n minus 1 factorial. That is the formula. Now, there is another formula in the case of, things which can be reversed. What do you mean by that? See, when people are sitting, A is here, B is here, C is here. Right? So, A will always be, or B will always be called as sitting to the left of A. C will always be called sitting to the right, immediate right of A. Yes? Now, if I take this case of, let's say, a necklace, and I have pearl A color, some color, B color, and C color. Now, in a pearl and a necklace, while A, B, C is like this, I can also flip it. You know what happens when I flip it? When you flip it, I'll get A position to be same, but now B is here and C is here. So, in such a case, I don't need n minus 1 factorial arrangements. Why? Because one arrangement of ABC will give me the other arrangement, the BCA. So I don't need to count them both separately. One will give me both. Why? Because I can flip it. The moment I flip it, it becomes the other arrangement. Whereas in people, you can't say I'll flip people, right? People are sitting. You can't flip things when people are sitting. So there is a requirement of only half the things when you can flip things over. That is the reason why you're talking about, when you're talking about necklaces and pearls and these kind of questions, arrangement can be done in n minus 1 factorial by 2 because you need only half the cases. You take half, the other half is already there. Is that clear? But for people, you can't say that. So people, it is n minus 1 factorial. This also will come to you for now. Keep it aside. Don't worry about this. We'll come back to this as a part of the questions. This basically says, this is basically for you to understand. This comes into the funda or the idea of number of positive or number of integral solutions. Positive integral solutions, number of non-negative integral solutions. This is the concept. We'll come to that later. We'll not learn all the concepts at the same time. We'll come back slowly. So that's enough theory now. Let's go ahead and solve some simple problems. First question, straight away simplify this. 10p3. What is the answer? Should be able to give the answer very, very quickly. 10p3. Yes? What is 10p3 formula? 10 factorial by 10 minus 3, 7 factorial. So this is 10 into 9 into 8. Because this remaining 7, 8, 6, 5, 4, 3, 2, 1 gets divided by 7 factorial again. So that's gone. So 10 into 9 into 8, 8 9s are 72 plus a 0, 720. Okay? C. Very simple. Okay, let's take another question. Find the basic total number of words that can be formed by using all the letters of the word basics. Now here, before you go ahead, let me give you a different example. Let us say Robin. If I ask you how many ways can you arrange all the letters of Robin? Now first of all, you notice that if you are arranging them, it's like as good as making 5 people sit in 5 places, correct? There are 5 places in Robin. So 1, 2, 3, 4, 5. And you can see R-O-B-I-N. Each letter is different from the other. So 5 people sitting in 5 places. What is the answer? The answer should be 5 factorial. This is the case where all the people are distinct. Right? Correct? Now, what is the problem here? What is the problem here? Why is this case not same as Robin? What is the difference? Very good. So the difference here is there are 2 S's. Now, people can be distinct, but I am taking the example of people. Here it's actually not people. These are letters. So now the problem is 2 S's are there which are identical, which means I cannot use my NPN or NPR formula. Why can't I use? Because this is to be used only when all the N things are distinct. All the N things are distinct. So now what will I do? So don't worry, there is a simpler formula for this. So please note down the formula here. The formula for arranging N things into N places where P things, P number of items are identical. So out of the N things, P of them are identical. But you want to arrange all of them into the same number of slots. Remember, this total places and total things are supposed to be same. They are repetitions, that's okay, but they are supposed to be same. How will you do this? There is a formula for that. It is given by N factorial by P factorial. It is given by N factorial by P factorial. Clear? So here the answer becomes 1, 2, 3, 4, 5, 6. 6 factorial by 2 factorial. 6 factorial by 2 factorial. So 6 factorial is 720. 720 by 2 is 360. It's 360. Now, what if I give you this HOLLY WOOD, and if I ask you find out the total number of ways in which you can arrange the word Hollywood. What is the problem here? First of all, how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 letters are there. What is the problem? The problem is 3 O's are repeating, 2 L's are repeating. Anything else? That's it. 3 O's and 2 L's. Now what should I do? This formula more or less remains the same. You will look at 9 factorial divided by, now because of these 3 O's you will get 3 factorial. This is what the formula says, but now it's not just O's, we have something else which is extra repeating. So for the 2 L's you will get into 2 factorial. So basically the denominator will keep having the number of things which are repeated. Okay, so this is the formula extension of it. If there are P things which are identical, then Q things which are identical, so it is P into Q, P factorial into Q factorial in the denominator. If there are another R things which are identical, divide by another R factorial. So that's how it keeps going. Simple? Okay, let's move on to the next question. Okay, now take a look at this. Find the total number of ways in which the letters of the word intense can be arranged such that no 2 vowels are together. No 2 vowels are together. So this is a very interesting concept. Let me give you an idea for this. So this comes under never together. Never together. So there are a lot of questions which say people should always be together, people should never be together. These are the 2 types of questions that can come to you. Sometimes you can get a mixture of these also, but for now we'll keep it simple. We'll take never together. So the funda for never together, first what is it? INTENSE. Now what are the vowels? The vowels are E, E, I. Okay, E, E and I. Now the funda for never together is first take out the others, which means the others are NTNS. See, I, E and E have a problem. They should not be together. So first pick the ones which don't have a problem. Who are they? N, T, N, S. First arrange them all possible ways. So 4 people in 4 chairs. How many ways can you arrange this? But remember, n is repeating here. N is repeating here. So 4 people to be placed in 4 chairs, out of which 2 people are, or 2 things are identical. So this is given by 4 factorial by 2 factorial. So job 1 is done. Job 1 is done. And now you want the second job. What is the second job? Now please remember, only the others are placed. You want the vowels also to be placed. So now what I will do is, I will look at 1, 2, 3, 4. Already we have some consonants, consonant, 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 vowels and consonants. We have 4 consonants already. They are arranged. Now look at the places. This is 1 gap, 2 gaps, 3 gaps, 4 gaps, 5 gaps. If I place my vowels in these 5 gaps, any of the 3 places out of the 5 gaps, any of the 3 places out of the 5 gaps, then my vowels will never be together. So my job is done. So never together, the logic to solve never together problems is, first pick the others who don't have a problem, arrange them. In between, count how many slots are there, including the endpoints. Then say that, okay, whoever should not be together, I will start putting them in these gaps. So now the question is, there are 5 gaps and 3 people, or 5 gaps and 3 letters. How many ways can you arrange that? That is given by 5p3. 5p3, but the job is not done here. Why? Because you can see that E is repeated. Whenever you are arranging things, if something is repeated, you will always divide it by 2 factorial. This is your final answer. So what is this? 4 factorial by 2 factorial is 2 into 5p3 is 5 into 4, 5 factorial. So let me write it, 5 factorial by 5p3 is 5 minus 3, 2 factorial into 2 factorial. So this is how much? 4 into 3 into 2 divided by 2 into 5 into 4 into 3 into 2 divided by 4. 4 gets cancelled, 2 gets cancelled. This is 12 into 15 to the 30, which is 360, option C. So remember, never together means keep the others, arrange the others first. In the slots, arrange the people who are not supposed to be together. Tarak, 5p3 is coming because 5 slots, 1, 2, 3, 4, 5 and 3, 1, 2 and 3. These also have to be there. So 5 places you are putting 3 things. How many ways can you do that? 5p3. Clear? Alright, let's move on. Take a look at this. 5-digit number that can be formed using these digits. Okay, so what's happening here? 1, 2, 3, 4, 5 digits. Now, I can start with the first digit, filling the first digit, because now what is my job? My job problem statement is, I want to fill all the 5 digits. So first digit and the second digit and the third digit, I have to fill all of them, right? Which means the number of ways of filling the first and number of ways of filling the second and the number of ways of filling the third and. That's my answer. So how many ways can I fill the first one? When I'm coming to the first digit, how many ways can I fill it? I can fill it in 1, 2, 3, 4, 5, 6, 7 ways. And becomes multiplication. Now I'm going to fill the second digit. But remember, repetition of the digits is not allowed, which means whatever is already here, I cannot use it again. If I can't use it again, out of the 7 digits, 1 digit is already written. So what is left out for me? Left out is 6. Then next, and I'm going to the third digit. Again, already 2 digits are written. Out of the 7, 2 are written. So the other 5 are available for me. 5. Similarly 4 and then 3. So the answer here is 7, 6, 5, 4, 3. So how much is this? 6 7s are 42, 5 4s are 20, 23s are 60. So this is 12, 24, 25. 2520, which is option B. That's your answer. Clear? Let's move on. Similar question now with a 0. Now whenever there is a 0 and you're forming digits, there is a problem. Why is there a problem? Because when I'm talking about a 6-digit number, 1, 2, 3, 4, 5, 6, my problem is if I say I want to fill the first digit, there is a problem. What is the problem? The first digit cannot be a 0, because if I say it's a 6-digit number, the basic logic is the first digit is not a 0. That is, the extreme left end digit is not a 0. That is an unsaid rule. They don't have to say that, right? So if I ask you how many digits are there in 0, 2, it's actually single digit, 0, 2. 0, you will not count it as a digit. So you have to make sure that the first one at the left is not a 0. So now if I ask you, let me start filling from the first one. Let me start filling from the first one. How many ways can you fill the first digit? Then you will say 0 cannot come there, but anything else can come. So what is the number of ways? 1, 2, 3, 4, 5, 6, 7. 7 ways. And now you are going to the other digit. But here repetition is allowed. Repetition is allowed means you can use the same number again. So now there is no problem with 0 and this number can again come back. So totally how many numbers are available for me? All 8 numbers are available. I can pick any one of the 8. And again 8. And 8. And 8. And 8. So your answer is 7 into 8 power 5. 8 power 5 into 7, which is option D. Okay, so you have to be very careful when there are zeros. You cannot start with a 0. And other thing, please keep in mind, whenever you're dealing with such kind of filling of numbers, always start with the digit which has a problem. Which digit has a problem here? The first digit at the left. Right? The first digit at the left has a problem. So wherever the place has a problem, start your journey from there. Start your journey from there. Let us say there are two places which have a problem. Let us say the same question if I ask you. If I have 0, 1, same question, but I am talking about 6 digit, if I say even numbers. 6 digit even numbers. So now what is the basic criteria? 1, 2, 3, 4, 5, 6 and I want even numbers. Which means problem is here and problem is here also. Why are there two problems? Because it is an even number, there is some problem in the last digit. I can't say anything can go there. And because 0 is included, the first one is also problematic. So now I am giving you a case where there are two problems. So in such a case, start from the place where the problem is the highest, or start from the place which will give you minimum number of available options. Now if you look at it, okay, this is actually a slightly more complicated case. If you notice, 0 can come here, but 0 cannot come here. So this is a particular case where 0 can come at the end, 0 cannot come at the beginning. So 0 is there in both the problems. So when 0, typically this case where 0 kind of a thing is there in both the problems, then you will ideally have to break it into two parts. Okay, you'll have to break it into two parts. What is the first part? So case 1, you will say that it is ending with a 0. Case 1, the number is ending with a 0. Case 2, it is not ending with a 0. Ultimately, it is an even number, it can end with a 0. It is not an even number, but not ending with a 0. Both possibilities exist. So now, take a look at this, add them both, because it is case 1 or case 2. So you have to add them both, that is your answer. Okay, so if you are saying it is ending with a 0, now this problem is solved. You are going now to the other problem. You will start from here. Now how many ways can I fill this? This can be filled in 1, 2, 3, 4, 5, 6, 7 ways. 7 ways. Now the others will be filled. So 7, 8 ways, 8 ways, 8 ways, 8 ways. This is 7 into 8 power 4. Now case 2. How many ways can you do or work in case 2? Now again this problem is not solved. I'm just saying 0 is not there. I'm saying 0 is not there, but anything else can come there. Correct? And here anyway 0 cannot come. Anyway 0 cannot come at the beginning. So now I have two problems. Where should I start? Start from the problem which will leave you with minimal number of options. So here, how many options are there? I have, in this case, I have 7 options. Whereas here, 0 cannot come, agreed, but it is an even number, which means I am only left with 8, 6 and 9. 8 and 6, only 2 options. So which of these two problems is giving you the minimum number of options? It is this problem. So start from here. So not a 0, so this can be filled in 2 ways. You can fill it with either 6 or an 8. Next, go to the other problem. Why am I going to the other problem? Because this problem has more options. More options means lower in criteria. Less options means higher in criteria. So now come here, and now you are saying that okay, it cannot be 0 and it can be any other number now, and which means this can be filled in 7 ways. Then everything else have no problems. So this is 7 into 8 power 4 into 2. So add them both, so this becomes 7 into 8 power 4 into 1 plus 2, which is 3. So this is your answer. This is if I change the question into even numbers. Is that clear? Okay. Let's move on to, so previous question actually answer is 8 power 5 into d, which we already discussed, but if I change that into even, then this will be your answer. Moving on. Let's take a look at this. Now what is the divisibility rule of 3? Divisibility rule of 3 is sum of the digits should be divisible by 3. So it's a very fascinating question. You have 4 digit numbers, 1, 2, 3, 4 and 5 digits given. And no repetitions. You cannot have repetitions. So what is the total number of ways in which you can form 4 digit numbers which are all divisible by 3? So the best way to solve this question is first add all these 5 digits. Let us say I am taking a 5 digit number. Let us say I am taking a 5 digit number, which means all digits are there. Correct? So what is the total? 2 plus 3, 5, 5 plus 5, 10, 10 plus 6, 16, 16 plus 4, 20. My total is 20. But now I want a 4 digit number only. So I have to take out one digit. Which digit should I take out such that the remaining 4 are multiples of 3? So I can take out 2, it gives me 18, or I can take out 20 minus 5, which will give me a total of 15. Nothing else. If I take out 3, it will not work. 20 minus 3 is 17, not a multiple of 3. 20 minus 4 is 16, not possible. 20 minus 6 is 14, not possible. The only 2 cases possible are you don't have 2 in it, you don't have 5 in it, which means the possibilities are, if you don't have 2, it is 3, 4, 5, 6. If you don't have 5, it is 2, 3, 4, 6. So 4 digit numbers using 3, 4, 5, 6. How many are there? 4 factorial, because 4 numbers, 4 places, 4 factorial now. Or it is 2, 3, 4, 6. Again 4 digits, 4 places. How many ways can you arrange? It is 4 factorial. So this is basically 4 factorial, which is 24 into 2, which is 48. So the answer is 48. Okay. Take a look at this. Aman has a total of 8 letters. In how many ways can Aman post these 8 letters in 5 different letter boxes? So look at it. There are 5 boxes. 1, 2, 3, 4, 5. Aman takes letter 1. How many ways can he post it, guys? Remember, what is your task? What is your task? Your task is letter 1 should be posted, and letter 2 should be posted, and letter 3 should be posted, and so on up to letter 8. All of them should be posted. Now, job 1 is posting letter 1. How many ways can you do this job 1? This job 1 can be done in 5 ways, because the letter 1 can be sent to any of the 5 post boxes. And now you're going to letter 2. You want to do the job again. How many ways can you do the job? There's no problem of sending multiple letters to the same letter box. So you can send anywhere. So again, all 5 are available. Again, all 5. So like this, 5s. So it is 5 power 8, which is option B. Which is option B. Okay. Now, if you look at this, once again, a very, very interesting question. Each question of an exam named FAT has 4 options. What is your option? A, B, C, D. A question has 4 options. There are 8 such questions in the exam. Find the number of ways in which Aman can attempt 1 or more of these 8 questions. Now please remember, you do not know how many questions are being attempted. It can be only 1 question, which means he is leaving all the 7. It can be 2 questions, which means he is leaving 6. It could be 3 questions, which means leaving 5, and so on and so forth. So what I will do is, I will first, what is my task? My task is to answer, I will say my task is answering questions 8 questions. I'll go to question number 1 and I'll ask how many ways can I do this? It's not 4 ways, it is 5 ways. What are the 5 ways? I can mark the answer as A, B, C, D, or beautifully I will say, I can also leave the question, which is the way of answering. So I will say leaving the question is also a way of answering. Which means my first task of question number 1, I can do it in 5 ways. Second question can also be answered in 5 ways. Third question can also be answered in 5 ways. Like this, 8 questions. 8th question can also be answered in 5 ways. So total number of ways in which I can answer the question paper is 5 power 8. But there is a problem here. What is the problem? there is a scenario, one scenario where I will go to first question and say, I will choose the option 5. What is the fifth option? Not answering it. I'll go to the second question, I'll say, I'm choosing the fifth option again. So basically, I'm saying that I'm not answering any of the 8, which is also a way of giving the question paper blank, correct? That's a way that is counted in this. But the question says, at least one should be attempted. One or more means minimum one question should be attempted. So the one case where I'm leaving all should not be counted. So -1. Hence the answer option D. Okay. So guys, we have reached the end of this particular session. We have a few more questions coming across, but these are, these questions require a lot of theory and understanding for you. So we will take it up once again. Don't worry. But yes, we have we got the CAT results this year. We have some excellent toppers. If you can see over here, we have these good gentlemen and women who have scored 99 plus percentiles, and if you're going to be a part of us in your CAT journey, hopefully I'll be making sure that your face is shown in one of my PPTs going forward. Okay, so we have this CAT 23 program, basically aiming at getting your faces onto this PPT probably the next year. So if you're interested in it, please join us. You can reach out to us by downloading our BYJU'S Exam Prep app, and the moment you download the app and enter your mobile number, we will get notice of it and we'll give you a call. So just download the app, and you can also go to a CAT section there and start answering questions which are given free of, there are a lot of free questions given out there. Okay. We also have a scholarship program for students who are smart. If you think you have the ability to answer questions, you can write our scholarship exam, which happens twice a month. 2 Sundays, alternate Sundays they happen. So if you download our app, you'll get the notification about the scholarship test. If you score well in the scholarship test, you can get up to 90% scholarship depending upon the score. Okay, very good score, maximum scholarship, lower score, lesser scholarship, and so on and so forth. Right? And of course, I'm taking a workshop on how to target 99 percentile. What should be your roadmap? What should be a plan for this for your CAT 23 exam? It's on 8th April at 7 p.m. So don't forget, I'm going to be there taking you through the process to target a 99 percentile in CAT 2023. This coming Saturday, 7 p.m. Right, so guys, I hope you've enjoyed the session. If you did, please be with us for the session number 2. And to get notification about that, click on the bell icon and subscribe to our channel. Thank you, my friends, and all the very best.